What if the solution to our energy crisis is hovering right above our heads? The world needs more power. AI is pushing our grids to the limit. There's a fuel that could fix this. It is clean, it is powerful, but it's stuck on the moon. We are talking about Helium-3. But why is it up there and not down here? The answer starts with the sun. This is the most important part to understand. Helium-3 comes from the solar wind. The sun constantly shoots these particles into space. Earth is safe from this bombardment because we have a strong magnetic field. It acts like a shield. It blocks the solar wind and protects our atmosphere. That is good for life, but bad for mining. It means there's almost no natural helium-3 on Earth. The moon is different. It has no magnetic field, it has no atmosphere. For billions of years it has been exposed to the solar wind. The lunar soil, the regolith, has soaked up these particles like a giant sponge. NASA estimates there are over 1.1 million tons trapped in the dust. It is a treasure chest waiting to be opened. But why the rush? Fusion power is still decades away. The real reason we need it now is for quantum computers and medicine. We use helium-3 to cool quantum processors to near absolute zero, and we use it in MRI scanners to see inside human lungs. But at Earth, our supply comes from dismantling nuclear weapons. And that source is drying up. The price is exploding. We are running out of the stuff that keeps our high-tech world running. So, the race is on. China is leading the charge. Their Chang'e missions have already brought samples back to Earth. The data is exciting. They found that a mineral called ilmenite traps the gas very well. China is not just looking. They are planning a permanent station. In the West, private companies are stepping up. Take Interloon. It was founded by former Blue Origin engineers. Their chairman is a legend, Apollo 17 astronaut Harrison Schmitt, the only geologist to walk on the moon. Interloon wants to dig deep. They plan to excavate the top 3 to 5 meters of the surface. But there's a rival strategy. A company called Magna Petra, they believe the gas is sitting right at the top. Instead of digging deep, they want to scrap just the top few centimeters. And companies like iSpace from Japan are building the landers to get them there. But here is the hard truth. No matter how you dig, the physics are brutal. The concentration is tiny. About 10 to 20 parts per billion. To get just 1 single gram of helium-3, you have to process 150 tons of regolith. That is the weight of a blue whale. For a thimble of gas. To get 1 ton of fuel, you have to move 100 million tons of rock. You have to heat to 700 degrees Celsius to release the gas. Doing this in the Helium vacuum of space is an engineering nightmare. The resource is there. The solar wind is delivering it. But unlocking it will be the biggest industrial challenge in history. Will helium-3 become the oil of the 21st century, or is it the most expensive dust humanity has ever chased?